All right, so we did the Bronsted acid-base reaction for this. Then we are going to look at the Lewis acid-base type reactions next. And so I think this is B. For Lewis acid-base reactions, you know, acids are defined differently. Acids are electron pair acceptors. Bases are electron pair donors. And so certain things aren't really classified as Bronsted acids, like for example CO2. CO2 is not a Bronsted acid because Bronsted acids are proton donors, but CO2 doesn't have any hydrogens to donate. But CO2 is called a Lewis acid. And why would it be a Lewis acid? What characteristics or what features do we look for in a Lewis acid? Well, a Lewis acid is going to be electron pair acceptor. And so we're looking for, you know, positively charged regions. And in fact, not all of CO2 is really thought of as being acidic. It's primarily this carbon. You know, this is the acid site of CO2. Acid site, because if you look at what is the oxidation state on carbon here? +4. The oxidation state of +4, it's positively charged region, and electron pairs are negatively charged, so there's going to be an attraction here. Well, the problem is it has an octet already, a full octet, so it doesn't want any more electrons. But if there's a way to get it to accept electrons, then that works. And so the titration, your color only has to last a short time. You know, the color only lasts a short time because CO2 will resaturate the water. And so what happens when CO2 and water react? Well, this is an example of a Lewis acid-base reaction. And Lewis acid-base reactions, what we do is we draw out the Lewis structures. And so it's a little bit more complicated. And so this is our acid here. And we're going to react it with a base. In this case, water. You know, water is either an acid or base, but we'll have it react as the base in this example, not the acid. Why? Well, it could potentially, but and so in Lewis acid base, what happens is we look at these electron pairs and what happens with those. So let's say this electron pair collides with this carbon atom here. You know, we'll look at the bonding later. There's too many electrons around here, 2, 4, 6, 8, 10. And carbon can't have more than an octet. And so what has to happen is, let's say it kicks out a pair of pi electrons, gives those to oxygen.